Okay, we already mentioned about contingency table. So actually contingency table, if we have a categorical data, if we have a categorical data, so that's mean we will arrange in terms of your contingency table where we have the R column and also, sorry, R, R times C and times C contingency table. So C is for column and then R is for your row. Okay, so okay, you have your observation from the data set and then you arrange in terms of your contingency table. So kita ada observe frequency where we have two variables. You have a column variable and also you have your row variables. So kita akan susun ikut dia punya categories lah ya. So let's say if you have O11, so that's mean observe frequency for the first row and then also for the first column. O12 again, we have for the first row, for the second column, O12, you have observation for the first row and second column and so on. So that is your observed frequency. So you have OIJ. Okay. So again, we have this kind of data set, okay, from the sampling that you done. Okay. So we have student, we have 10 students, and then we have a gender, male and female, and then we have a statistic test result. So in this case, we have two variables. So you have a gender and also statistic test result. You want to check whether the statistic test result is independent of the gender or not. Okay, you want to test the independency. So from this observation, you put in contingency table. Okay, so we have, for example, again, 3 male students pass the statistic test result and so on. Okay, so after that, what you need to do is to compute the total for each row and also total for each column, and then we have a grand total. Okay, so the question we want to answer when dealing with contingency table, if either statistics test result is either related or not related to gender of the student. Okay, so there is only one way how you can write the null hypothesis and also alternative hypothesis. Okay, for example, in this case, when we conduct independent tests, you have your null row variable is independent of your column variable. Or the same thing, you can write row variable is not related, as long as the meaning dia maksudnya in your null hypothesis, it should be independent. Okay, in your alternative, row variable is not independent, so it should be dependent or related. Okay, row variable is related to your column variable. Okay, so there is only one way, writing your null and your alternative. Okay, so then we proceed to find your expected frequency. So expected frequency in here, okay, so it should be EIJ, EIJ, so that's mean total for first, let's say if you want to find E11. So total for first row times total for the first column divided by grand total, and then we proceed E12 and so on. Okay, so last you use the chi-square test. Okay, so in this case you have double summation because you have I and J. Okay, I is for row and J is for column. So you have OIJ minus EIJ squared divided by EIJ. So again, this test statistic, okay, we only consider one-sided test. Okay, so we will reject your null hypothesis if you have your chi-square value in here, chi-square test is greater than chi-square alpha. Okay, your degree of freedom should be R minus 1 times C minus 1. Okay, times column minus 1. So that is what we already did in the previous class. Okay, for this example. Okay, for today, kita continue on one more example for independent test. Okay, you just refer to example, I think, example 6.5. Okay, example 6.5. Okay. Again, in here, so you have a data set in terms of your contingency table. So now you have your row is equals to, you have 3 rows and then you have 2 columns. So that's mean you have 3 times 2 contingency table. Okay. So what you need to do is to find the total for first row, second row, the third row, and then also total for the first column and also second column. For example, let's say if we compute this one, okay, for example, you add on total, okay. So you have this one 70 and then 80, and then you have 40. So this one you have 35 and then 45. And again, you have 80 plus 65, so 145. Okay, So again, you will total up. Okay, total up dia punya value dia. So again, in this case, you will have total is 190. Okay. So again, you already have your observation. Okay. 011, this one is 012, again, this one 021, 022, and so on. Okay. So now you write your null and your alternative hypothesis. The first step, writing your null and also writing your alternative hypothesis. So your null in this case, okay, we have testing level of intensity of injury sustained by victims in car accident depends on seat belt wearing at significance level. So we just write down in this case, you want to check whether the level of intensity, okay, copy back the question, okay, of injury, okay, okay lah, by sustained by victims in car is independent. Kita nak tengok the word here is independent on seat belt wearing lah, okay. So in your alternative, the same thing. Okay, this one is dependent. Okay. So in your null hypothesis, the keyword is independent. Your alternative should be dependent ataupun is not independent. Okay, so the same thing. Ini kita punya basic tadi. So kita dah tahu dia punya ni. So in your null, it is independent. In your alternative, it should be not independent. Okay, so just write down that one. And then you compute what is your expected frequency. Okay, so that's mean you have 6 categories or 6 cells. Okay, so compute for each value. Okay, compute for each value and then you get your E11, E12, E21 and so on. Okay, so we try to compute this one. Okay, but it must be corresponding to your total, total for first row. Let's say if you want to find E11 in here, okay, E11, so you will have total for first row times total for second, total for first column divided by grand total. Okay, for example, in this case, you will have 45 times 70 divided by 190. And then we will have E12. Okay, so we have 145 times 70 divided by 190. And then we proceed until we have the last value. Okay, cuba compute dulu. And then you list down what is your expected frequency. Okay, list down in terms of put in table. So what is your expected frequency in this case? Okay. Okay, let's say I go to the next slide. Okay, so we just put OIJ here, and then you have EIJ, and then you build up your chi-square. Okay, so OIJ, so you have 20, 50. You have 15, 65. Then you have 10, 30. Okay, in your step, okay, dalam kerja tu, so make sure you tunjukkan E11. Okay, E11 you have 70 times 45 divided by 190. Okay, so you have 70 times 40 times 45 divided by 190. So get the value. What is the value? Okay, and then you have E12. So E12 for 50. So again 70 times 145 divided by 190. Okay, so the third cell, it should be for 15. Saya ke bawahkan sikit. Okay, try to find the value. Find the expected frequency. And then you have your 15 after 15. 65. Okay, so fill the value. The last one, you should have 145 times 40 divided by 190. Okay, so find for the value for expected frequency. Okay, so you need to find EIJ. So find E11, E12, and so on lah sampai E32. Okay, cuba dapatkan dulu dia punya value dia. And last, baru kamu compute dia punya chi-square. Okay, double check dengan saya punya jawapan. So you have this one, you have 16.579. Okay, so E12, you will have 53.421. And then this one, E21, 18.947. Okay, for observation 65, you have 61. So 053, and then you have 9.474. And then the last value, you should get 30.526. Okay, so that one is your EIJ. Okay, now you try to compute your chi-square. So give me the last value of your chi-square. So the same approach. So chi-square is just OIJ minus EIJ. And then you square the value. Same thing kamu repeat kan. So dalam kamu punya solution, tunjukkan setiap satu jangan dot-dot pula ya. So tunjukkan semua lengkap kamu punya kelas jalan kerja. Tak lengkap markah apa separuh. Okay, so find your chi-square. Total up dia apa? Okay. Do you have the value for the chi-square? Ada yang dah total up? Okay, dah dapat ke? Dia punya value for chi-square? Anyone? What is the answer? Okay, you get 2.0253. Dan the rest ada tak jawapan lain selain pada ni? 2.041. Okay. 04. Okay. So saya ambil 3 decimal points, so 2.041 Okay, thank you. 04. Okay, so you have your chi-square value. So dia kalau boleh bila kamu total up tu, okay, total up dia punya chi-square tu, the last value tu baru kamu roundkan to 3 or 4 decimal point. Okay, jangan roundkan awal-awal dia punya ni. So mungkin ada perbezaan sikit lah. Dia punya jawapan tu. Dia lari sikit lah in terms of dia punya apa nama? Decimal point. Okay, so this one I think it should be 2.041 lah if you take 3 decimal point. So next step, okay, since we already compute your chi-square is 2.041, so you will compute your, write down your, decision rule. So we will have reject H naught. If we have a chi-square test greater than chi-square alpha, so in this case, your alpha should be 0.01. Okay. So again, degree of freedom. So degree of freedom is just R minus 1 times C minus 1. So your R is 3, your C is equal to 2. Okay. R is for your row. You have 3 row, 2 column. Okay. So in this case, 2. So find from your stats table. Okay. Chi-square alpha 0.01, degree of freedom 2. Double check. Let's say if you have 9.2103. Okay. So again, since you have your chi-square test, so chi-square is 2.041 is less than chi-square alpha. So in this case, fail to reject H naught. Okay, fail to reject H naught in this case. So that's mean we accept our null hypothesis. So we conclude that the level of intensity of injury sustained, or you can say that there is evidence that to indicate that the level of intensity of injury sustained by victims in car accident is independent on seatbelt wearing. Okay, sebab kita accept kita punya null hypothesis, so it should be independent. Okay, so that is your answer in this question. Okay,